Alright, so this video is going to be for my calculus class section 1.3, and we're going to start off with some shifting and translating functions. That's something that we did in the last video. And so here I have a graph of y equals a times b to the x minus c plus d. And so basically, as I sort of discussed before, there's going to be our A is going to do a vertical stretch. You can't really see it there, but so if I make my B is going, right now B equals 1 in this case gives me sort of my maximum horizontal stretch. If I make B equal to 2, it's going to, I want to make A equal to 1. There I'm going to go. So here I've got, if I change my B from 2 to 3, you probably can't see that over on the video, it's going to stretch it. I wonder if I can make it n. Probably not. No, it doesn't let me make it n. So that B is going to be the horizontal stretch, A is going to be the vertical stretch, and C is going to translate it to the right, and then D is going to translate it up or down. Okay, so if I sort of get rid of those, and if I do y equals 2 times 3 to the x minus 2 plus 4, and then I compare that to y equals 2, let's call that 3 to the 2 to the x minus 4 minus 2. So what's happened is I've taken this graph and I've given it more vertical stretch in going from 2 to 3. I've given it less horizontal stretch in going, no, I've given it more horizontal stretch in going from 3 to 2. I've given it less of a horizontal, I've given it more horizontal shift in going from 2 to 4, and then I've given it a lower vertical shift in going from positive 4 to negative 2. Okay, so there's just one that sort of ties over from last class. I'm going to give you a couple other examples here. Let's go to our good old friend the ellipse. Let's do our standard ellipse of x squared, get out of that, divided by, say, 4 plus y squared divided by, say, 9 is equal to 1. Okay, so there's our value there. So now we have to look at what can we do to stretch it. What can we do to stretch it horizontally? Well, what's our horizontal stretch? What change can we make to stretch it horizontally? Think about that. Okay, I'm going to copy this. I'm going to paste it there. What can we do to stretch it horizontally? Let's put in a 1. Ah, that does not stretch it horizontally. It compresses it horizontally. So let's go to 8. That does better. So that stretches it horizontally. And then if I want to stretch it, vertically, maybe do the same thing, increase that. Yep, that stretches that vertically. Got that right. Okay, so then how are we going to shift this thing? Let's change it back to 4 and 9. How are we going to shift this red one to the right? How are we going to shift it to the right? Okay, the way we're going to shift it to the right is going to do this. Now that's shifted to the right. How are we going to shift it to the left? That's shifted to the left. What are we going to have to do to shift it up? Well, shifting it up, let's try this. Oh, wait a second, that didn't shift it up, it shifted it down. Interesting. So that shifted it down, and then if I do that, that shifted it up. I'm going to rewrite this. I want to rewrite this as, let me do a whole new thing. I'm going to do 1/4 times x minus 2 squared plus 1/9 times x minus times y minus 4 squared. And so what that's going to do, let's make that a 16 and let's make that a 4. So what this does is it takes my original equation and it moves the center of it. So it moves the center of it from 0, 0 to the point 2, 4, and it stretches it from having sort of a horizontal width of 4 to now having a horizontal width of 8, and instead of having a vertical width of 6, it's now going to have a vertical width of 4. Okay, so this right here, that right there is my horizontal stretch. That right there is my horizontal shift. That's my vertical stretch. That's my vertical shift. Okay, and I got a lot to fry in this video, so I want to go on to y equals sine x. Okay, so there's y equals sine x. Now I want to think about what can we do to that to stretch it vertically. So think about what I can do to stretch it vertically. That's what I can do to stretch it vertically. Multiply out front by 4. What can I do to stretch it horizontally? Well, in order to stretch it horizontally, I just have to multiply in front of the x, and it's going to stretch horizontally. No. Remember sort of what I was talking about in the last video is that these numbers that these numbers that are attached directly to the x's kind of work backwards. So if I want to stretch it horizontally, I've got to multiply it by a number less than 1. That's going to stretch it horizontally. If I multiply it by a number greater than 1, I'm going to compress it horizontally. Okay, so I've got vertical stretch, horizontal stretch. How about vertical shift? Vertical shift shifts it vertically, just like that. How about a horizontal shift? Well, horizontal shift, let's see if we remember. if I do it backwards, so there I've taken this point here, I've taken that point there, and I've shifted it to the right by 2. So again, it's a little bit backwards. So if I throw them all together, what this is going to do is it's going to, I should actually do it this way. Sorry. That's what I want to see. Okay. What it's going to do is it's going to take this point here. It's going to take my point 0, 0, and it's going to shift it to the right. It's going to shift it to the right to, it was right on it, there it goes. It's going to take the point 0, 0, and it's going to shift it to the right by 2, which is right there, and it's going to shift it up by 2.8, which is right there. And instead of having an amplitude of 1 going from 0 to 1 or from -1 to +1, it's going to have an amplitude of 1.5, so that that distance to that distance is going to be 3, and it's going to give it a compression where in the space that I get one of these, so in the space that I get one of these, I'm going to get 1, 2, well, hang on a second, let's go back to like right there. I'm going to get 1, 2, 3 of the red. So in the space that I get 1 pink, I'm going to get 3 reds. Okay, so there's some things to think about on horizontal and vertical shifts and horizontal and vertical stretches. Just heard a review from pre-calculus, and I got a lot of things I want to get through. Okay, so next thing that I want to talk about is I want to talk about odd and even functions. Okay, so let's give you an example. Y equals x. Okay, I'm going to call that, I'm going to do x to the 1. That's going to be an odd function. And what's going to make an odd function is that f of x is equal to f is equal to negative f of negative x. Or let's put it this way. I want to do this. F of negative x is equal to negative f of positive x. That's the true for odd functions. So if I plug in x equals 2, I get y equals 2. If I plug in x equals negative 2, I get y equals negative 2. So x equals 2, y equals f of x, f of 2 is 2, f of negative 2 is negative f of 2. Okay, so there's, well, we're going to get into some other ones here. Another odd function for you is that one, x cubed. So here I've got 1.28125 and 2.1, and then if I go to negative 1.25, whatever, somewhere in there, negative 1.25, I forget where I was. But this function here is sort of both the negative, if I switch to a negative x, I also switch to a negative y. Let's look at even functions. even functions. Here's our good old even function. In this case, f of x is equal to f of negative x. So if I plug in x equals 2, I get y equals 4. If I plug in x equals negative 2, I get y equals 4. So the f of 2 is 4, and the f of negative 2 is also 4. So f of x equals f of negative x for odd functions. And so then if I sort of do a whole bunch of them, I do y equals 5, then I go y equals x, I do y equals x squared, y equals x cubed, y equals x to the 4th, and I got a whole bunch of them there. Okay, so too many of them. So let's look at them. Let's take some of these out. Okay, why in the world is y equals 5 an even function? Well, because I can rewrite that as 5 times x to the 0. And I can rewrite this one as x to the 1. So I've got 0, which is an even number, gives me an even function. X to the 1 is an odd number, gives me an odd function. X squared is 2 is an even number, so I get an even function. Then I've got x cubed. Let's do that one in blue. And let's take this out. X cubed, 3 is an odd number. And then 4 is an even number. So I start with these numbers. Where do these numbers come? Where do these names come from? Odd and even. Okay, so basically they come from this idea that x to the odd number gives you an odd function and x to the even number gives you an even function. Okay, so then we got to sort of play around with that a little bit more and look at some other things. So if I've got y equals x cubed plus x to the 1st, this is an odd function and this is an odd function, and an odd function plus an odd function gives me an odd function. An even function plus an even function gives me an even function. An even function plus an odd function gives me non-symmetrical. So this is neither even nor odd. So this is not symmetrical. So the terms even and odd do not apply to this function. Similarly, if I say x plus 5, that's an odd function, that's an even function, and so I get a function that is not symmetrical around the origin or is not symmetrical around the y-axis. Okay, so there's a few things, and so if I go, there's functions times functions. So if I go x to the 4th minus 2x squared plus 3, that's an even minus an even plus an even should be even, and it is even. And if I change that, let's make it 5, 3, x, odd, 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 and that also gives me an odd function. Okay, so now let's look at, how about a odd function divided by an odd function. Well, if you know your exponent rules, x to the fifth divided by x cubed is going to be x squared. X squared is an even function, so odd divided by even gives, odd divided by odd gives you even. So this is odd divided by odd gives you even. How about even divided by even? You're going to get the same thing. Even divided by even is even. How about odd divided by even? Well, odd divided by even, that should be odd. And it is odd. So whatever value here I get a corresponding value over there. And then if I do even divided by odd, I get the same thing. I get odd. So odd divided by odd is even. Even divided by even is even. Even divided by odd is odd. Odd divided by even is odd. Okay. Let me get into that a little bit more. So then, if I take a big even number, or even function, let's do this one that we just did, 4. Well, let's just come up with that. There is a very large, complicated even function, and then down here, x cubed minus 2x. That's an odd function, so I have an even function divided by an odd function. It should be odd. And that looks kind of really funky, and it is really funky, but I will notice that this point corresponds to that point. That point corresponds to that point. And so if I plug in negative 1.12281, I get 1.863, and if I plug in positive 1.12281, I get negative 1.86312. So the definition that f of negative x is equal to negative f of x holds, and so it is an it is an odd function. Okay. Sine x, even or odd? That's an odd function. Cosine x, even or odd? That's an even function. Sine x plus cosine x plus sine x. That's an even function plus an odd function. It should not be symmetrical around the origin. And it's not symmetrical. It doesn't go through the origin. It's not symmetrical around y. It's not symmetrical around the origin. But cosine x is an even function. X squared is an even function. So that should be an even function. And it is. If I do x is an odd function times sine x, that's an odd function. An odd function times an odd function should give me an even function. And sure enough, that's what I get. An odd function times an odd function gives me an even function. Going through it really quick because we got a lot to fry. Okay. What about other? So then don't carry this too far. E to the x. That's neither even nor odd. So there's a lot of really good functions that are not even or odd. If I do x to the 1/3, that is an odd function. But if I do that, that's not an even function. And that's I'll leave you to think about that on your own. Okay. Then moving on, the last thing that I want to talk about, because I got a lot to do in this video, is inverse functions. So we talked about how if you've got y equals e to the x, and then you got y equals ln of x, that those functions kind of undo each other. So if I do y equals e to the ln x, or if I do y equals ln of e to the x, basically it's just giving me a straight line. It's just giving me y equals x. So this function undoes this function, and you can see on our graph that functions that undo other functions are symmetrical around the line y equals x. So again, let's see if I've got this one. Let's back it up. Y equals x cubed, and then I've got y equals x to the 1/3, and if I sort of do y equals x cubed to the 1/3, the cube and the 1/3 are going to undo each other. Okay. Last one that I want to do is if I do, well, I'll probably do more. Y equals sine x, and then I'm going to do y equals a sine of x. Now, this is really, really critical, that this function y equals the sine inverse of x, that's only defined on this interval from -1 to +1. Why is that? Okay. We've done horizontal rule. Well, there's the horizontal line test, and sine x always passes the horizontal line test. I'm sorry, vertical line test. So y equals sine x passes the vertical line test. Every vertical line passing through this function only hits the graph in one spot. But a horizontal line passing through this function passes in an infinite number of spots. So in order for that, so in other words, I can't write x as a function of y for all values of y. And so basically what I have to do is I have to choose a piece of it. I have to choose a piece of it on a restricted domain. And so I'm going to say negative pi is less than x is less than pi. Let's see if I did that too much. Pi over 2. There we go. Okay, so what this is saying, we've sort of talked about domain and range, is that the function y equals sine of x only has an inverse. It only has an inverse over the restricted range, over the restricted domain of negative pi over 2 is less than x is less than pi over 2. Beyond that, I can't find the inverse of it. Similarly, if I say y equals x squared, well then you say, well great, my inverse of that is y equals x to the 0.5. Only on the interval where x is, where 0 is less than or equal to x. On this range, I'm sorry, on this domain, y equals x squared has an inverse only as long as x is greater than 0. So The only functions that have an inverse over their entire domain are functions that pass the vertical and the horizontal line test. So this function here passes the vertical and the horizontal line test. So I can find an inverse function for this over its entire domain and its entire range. But if it doesn't pass the horizontal line test, it's only going to have an inverse over a restricted domain. And that's about all I really want to say in this video.